Hello! So today we're going to continue building our data structures in C, picking up basically where we left off in the C++ library with the queue. And just like in our C++ version, our queue is going to be a version of the linked list. So we are going to model the inheritance of C++ here in C using structs. Before we get into that, though, I want to point out something that I learned in between this episode and the previous one, and that is this right here. So this is my node struct from the previous episode, and if you remember, I had node int as the name of this struct, and then this pointer was a pointer to an integer. And I found that I can do what is called a void pointer. So this line right here is a void pointer. And a void pointer is going to hold a memory address. And it will hold a memory address of anything. So it can be an integer, it can be a character, it could be whatever you want, a Boolean. So by using the void pointer, I was able to make my node dynamic. And now I can store any kind of data I want in it. However, this comes at a cost. So if we look at my actual test here, you'll see that I have to actually allocate the data I want to store to the heap with malloc before I actually insert it into the list. And if we look at my create node function, you can see here that I pass in the void pointer for data, and then I have to call malloc again to put the node itself on the heap. So I'm essentially having to call malloc twice. I allocate the actual data to the heap, then I allocate the node to the heap, and then I use the void pointer in the node to point to where the data is on the heap. Also, when I call the destroy function and free these, I have to free the data first, then the actual node. So this is going to take a little bit more processing time. It's a little bit less efficient than actually declaring the node as a node that's going to store an integer. However, in most cases, I'm willing to bet that this will be fine, and it won't be a problem that this extra processing needs to take place. And also, by building my generic linked list class like this, if I find later that there's an instance where I need it to be a little faster, then I can create my specific node int and have a linked list specifically for that situation. So the generic class is going to fit most situations, and if I need a specific one, I can go ahead and build that. And one last downside is just the implementation here. So this is a little bit less pleasant to work with than having the node specifically for an integer, or even a class template in C++. I have to remember to allocate the data to the heap before I can actually insert it into the node. Also, when I want to retrieve the data, I have to cast what I have retrieved back into an integer pointer and then dereference it. So the usage here is a little bit less elegant, and it's going to take a little bit more processing time. But the benefit is that my node has become dynamic, and now I can reuse this exact linked list for pretty much anything. Okay, so today we are going to move on to the queue. So I'm going to create a new file. We'll call it queue. And just like how the queue in C++ inherited from the linked list in C++, the queue in C is also going to inherit from the linked list in C. And you'll see how I do that. Essentially, it's not actually inheriting anything. It's just that the list is part of the struct. If we think of this in object-oriented terms, we would usually talk about is a versus has a relationships. And in C++, by using inheritance, I can create is a relationship. So I can say that a queue is a linked list rather than a queue has a linked list. But in C, we don't have that sort of inheritance structures. So either I am going to create a queue from scratch that is going to have its own node. Well, actually, I could probably reuse the node, but it would have different functions for these linked list things and all of that. Or I could inherit my linked list by saying that it is a member of the queue. So let's do it that way to start with. First, I want to include linked list.h. And I'm going to define the struct. And we are going to say that it has in it a linked list. So and then we are going to have some functions in it as well. So again, just like in my linked list, I'm going to have these functions, function pointers that I will override in the actual C file. And this is going to have pop and push. Those are the two. And the way a queue works is that when you take something out of the queue, you're always going to take whatever is first in line. And whenever you're putting something new into the queue, you're putting it at the end of the line. So in this sense, a queue is exactly like a linked list, only we have predetermined places for these objects to go. So I'm going to say, let's put that up side by side so I can refresh my memory on the syntax of these because I kept doing it wrong the last time. So we'll call void, we'll call this push. And what is it going to take? Basically just the data, so a void pointer to the data. And that's all it's going to need, is it? All it's going to need? Probably. So it's going to also need the list itself, and I'm going to have to pass the list in. And what I did over here was I had them pass in a pointer to the linked list. And over here, I can have them do the same thing. They'll pass in a pointer to that linked list. But instead, it's a little bit unpleasant if you're trying to work with a queue and you have to keep referencing the linked list that is embedded within the queue. I can just have them pass in the address to the queue. That way it still makes perfect sense, and it will just get the list embedded itself. So we'll pass in queue, pointer queue. And then we'll have pop. And this one will just pass in and this is going to return a void pointer, and this one is going to return nothing, because the way I want my pop function to work is that when you pull the item out of the list, it's not going to retrieve the node, it's going to retrieve the data, and the data is a void pointer. In push, we don't need to return anything because we're just putting something into the list. So we pass data in here, and we pull data out here, both of which require a reference to that queue. All right, so let's define our functions over here. So we'll call a constructor first, and in fact, I need a prototype function for that constructor. And I always want my users to use this constructor when instantiating a queue. So let's do that. So we'll call this void, nope, we're going to return a queue, and we're going to call this queue constructor. And they don't need to pass it anything. Okay, so let's define that. And what we'll do first is create a new list object or linked list object. Struct. I'm still thinking in C++ where we can just reference these objects by their original name, but here we need to actually specify that it's a struct. And just for your information, we can actually define this as struct without having to use the struct by saying q at the end. I think that's not quite the right syntax. Maybe it's define struct q and then put q at the end. I don't remember exactly what it is, but I don't mind just writing struct, and I think it's a little bit more clear. I tend to avoid little shortcuts like that when I code, just for clarity's sake. So let's define this. So list, we'll say we're going to create a new struct. Okay, I know what I'm doing. Struct q, and then we're going to say q dot list equals linked list constructor. So we'll call our linked list constructor to actually create this list. And then we will define push and pop. So I need to have those first. So I'm going to call void push. This will be passed a void pointer data. And let's clean that up. And it will be passed Q pointer Q. And I need to say struct. Okay, and the push function is going to put something at the very end of the list, so the length of the list. So let's refer back to our linked list. And do we have a way to get the length of the list? We do. We can actually just access it directly. So this push function is simply going to say Q list, and this is going to be dot insert, and we'll pass it data, and we'll put it into the, well, let me remind myself of the syntax of my function here. So insert, we pass the index first, so we'll say Q list dot length, because we want it to go at the end. We're going to pass it data, and we're also going to pass it an address for this specific list. So we'll call the address of operator Q list, and that's all we need. And is that all we need? Yeah, that is all we need. So it's by doing it in this inheritance way, it's a lot easier to create these functions. I have to do very little in order to make a queue. Essentially, I'm just calling the insert function with some given parameters already. So this function is quite easy. And I'll also need pop. So we'll pass void pointer pop. And this is going to take just the address of the queue. So struct q pointer q. And this is going to return, and we need to get the item that is in the first and actually remove it. So first we are going to get it. So we'll say void pointer data equals, and let's pull, we got that actually, retrieve from the list. So q list dot retrieve, and we want to retrieve the index 0, and we'll pass it the address of q list. So that essentially extracts our data from the list. Now we need to remove that first item from the list. So we are going to say q list dot remove, and we only need to pass the remove function the index, which is always going to be 0, and then the address. So at q list. All right, and then we can simply return data. And that should be fine. And I don't need the semicolon there. I was thinking of my struct. Let me check to make sure I actually did that. Always put a semicolon after your struct. I don't know why that's necessary, but C seems to appreciate it. Anyway, so let's pull this back up. And our constructor, now we just need to set these functions equal to their definitions up here. So we'll say q dot, what did I call it? Q dot push equals push, and q dot pop equals pop. And that should be all that we need. So if I come back to my test file, and instead of including linked list, I'm going to include data structure / q.h, and we'll say q list, and instead of, what do we want? We want the q constructor, and we're going to still do all of this. We'll q dot push, and then let's do q dot pop. So if I run this, let's make sure it actually works. And the address of q and the address of q. Is all that good? No? Doesn't like that. Oh, I still called it list. That's not perfectly clear, but, and that. All good? No, still doesn't like it? Where am I saying Q? list. Should have just changed the variable name. And what does it not want? Oh, and here, since I'm calling pop, I actually don't need the index. And here in push, I don't need the index either. I just pass it the data because the index for these is predetermined in the C file. And that's actually the point of the queue. So now when I run this, the output should actually look exactly like that. Struct. And we need to say void. Syntax errors, gotta love them. Okay, and this is a library, so I need to actually compile it a little bit differently. So let's go to libc, I believe it's in here, and we're going to gcc test.c, and I need to actually link it. And then we're going to, what is it again? And where is that? Non-void function does not return a value. Where do I forget to return a value? Ah, I need to return my queue. Of course. Okay, so now if I /a.out, we get our queue. 1, 2, 3, 4, 5, 6, 7. Did I only do? Oh yeah, because if you remember in my original, I changed this here because I was doing some pop functions. Let's actually do that. Let's do that twice. So we'll say list.pop, and we're going to pass it and list. And then we'll say list.pop and list, just to make sure that those functions are working fine independently. So let's compile it again and run it again. And there we go, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that it is always putting things in the back, so the higher numbers are lower in the list, and it is always pulling things from the front. And this just allows our interface with the linked list to be a little bit more controlled. And that is, again, just the point of the list, or the queue. It is to force us to use the list in a particular way. Now, unfortunately, it's not quite as secure as it would be in C++. So for example, I could say list.list.insert, and now I can actually insert something anywhere I want to in my linked list. And that's not how I want to use the queue. In C++, I was able to define the inheritance relationship as protected or private, thus giving the class itself access to the linked lists functions, but not someone instantiating the class. So in C++, I wouldn't be able to do this. In C, however, since this is kind of a has-a relationship in an object-oriented framework, I still have the ability to manually do things wrong. So that is one of the liabilities here. So that is going to be it for today. We have successfully created our queue object. I'll do a little more cleanup just to make all of this aesthetically pleasing. And as always, you can download the code from my GitHub, which you can find in the description. And both my C library and my C++ library are open source and available on GitHub. So feel free to download the code, edit the code, use the code, do whatever you want with the code. And that will be all for today. So as always, thank you for watching. Feel free to subscribe and like the video if you're inclined, and I will see you next time. Toodaloo.